All right, there we go. So we're now recording. So again, just to pick up with what I was saying, I was wondering if people would want an additional office hour this week, because again, this is going to be the final week of standard office hours before finals week. Finals week, we have our one office hour on Monday. We have a break on Tuesday because the Tuesday by the college is supposed to be like your study day or something. And then our final is on Wednesday. So again, just wanted to see if people wanted to take advantage of an extra office hour. If you don't, then that's fine. So I'm just gonna go through by quick show of hands and see, just real quick, not to vote for a day, but would anybody want a third office hour this week? Just raise your hand if it's something that you feel like you'd take advantage of. Okay. All right. That's enough for me to warrant a yes. So, all right. So, given that, why don't you guys put your hands down and we'll figure out the best day for most of you that, to be able to come. So, all of these times are going to be the standard times of 4:15 to 5:15. So, just assume normal time, 4:15, 5:15. So let's do Tuesday first. If I could just have a show of hands, how many people can attend Tuesday? Even if it's not your first choice, I just want to make sure that I can, put it down there just for the sake of if more people can attend it. Okay, so 6 for Tuesday. All right, great. How many people can attend Thursday? Okay, 7 for Thursday. And lastly, how many people can attend Friday if they wanted one on Friday? Okay, so 7 for Friday as well. So what I'll probably end up doing is just for sake of convenience, a lot of people don't necessarily like going to office hours that late anyway, 4:15, and I imagine that, ahead of the weekend, a lot of people are going to lose interest. So why don't we go ahead and plan for an extra office hour on Thursday then? If anybody has any scheduling conflicts with that, they really direly want to go to an office hour and they can't make it on the normal Monday or Wednesday, and they definitely can't make it Thursday, just talk to me. We'll plan something. And obviously now this also means that Tuesday and Friday are open. So Thursday, that's what we're going to do for our class. Okay, so plan for that. Okay. So with that being said, just before we get into the actual math stuff, let me just run through some quick boilerplate stuff that I have to. There's a decent amount to talk through. Sophia, what day is the final? The final is on Wednesday, so I'll write this out just so everybody sees. The final is on Wednesday, and so Wednesday the 9th? I think it's the 9th. It's next Wednesday, which I believe is the 9th. So it's Wednesday the 9th, and it's at 11 a.m., and it runs until 1:30 p.m. So 1:30 p.m. Okay, so this is our final. Again, what you're going to do is you're going to just show up to our normal Teams meeting, same as you normally would. You're going to just stay in the call until you're done, and when you're done, then you just do the same stuff that you've always done for like your quizzes, right? You scan it, you make sure that you have your name on it, with the scan, not your paper. I don't care if your name's on the paper. Just make sure that your name is on the scan, and then you send it my way. I am going to open it up. I don't normally open up your files that same moment, but I am going to open up your final that day when you send it to me, just to make sure that all of the work came through, and that you're okay with your work, that this is the completed version of what you're sending me. And if that's the case, then that's it, then you're done. I'm still deciding back and forth whether or not I'm actually going to be returning your finals to you. The reason that this is back and forth is because for all other classes, when we haven't been, in COVID mode teaching online, you normally wouldn't get your final back. You would take your final, you'd get a grade for it, but you really wouldn't see what you did wrong, right? You know, in general, seeing what you did wrong is giving you a chance to learn from your mistakes. So it's not as important for the final, but because this is online and there's really no reason not to, I might just send you your final back anyway, just to show you exactly, you know, where you're losing points or, you know, something to that effect. Haven't decided on that yet, but point is, either way, you know, you just take your final, just like we've been taking with our quizzes. You show up, make sure you're in the Teams call, and that's it. Okay, good question though. I'm glad Sophia asked, because we definitely, I want everybody to know to show up Wednesday the 9th, or there's going to be some big problems for sure. So Wednesday the 9th, make sure you show up. Okay, how long is the final? Well, it runs from 11 a.m. to 1:30 p.m. So that's 2.5 hours, I think, right? Unless my math is just letting me down here. Yeah, 11 to 12, 12 to 1, 1:30. Yeah. Okay. So, with that being said, again, just some more boilerplate stuff. So, I got an email from the chair of the mathematics department, and basically this is entirely optional. It's something that they just want us to share with our students as an optional assignment if you want to do it. Basically what the department is looking for, what the college is looking for in general, is they're looking for any student who wants to volunteer in 100 words or less, a positive, innovative, or engaging experience that you had this year in or out of the classroom after going remote. So basically, they're just looking for positive anecdotes after, you know, we went to distance learning or online learning. So if you have a story, you know, that happened you know, over the course of this semester after we went remote, and it's something that you feel like you wanted to share, sure, that's fine, that's great. Let me know, I'll give you the contact information, you know, the email that you need to submit it to, and that's that. I have no stake in this. There's nothing like I don't see this unless you want to share it with me. This goes directly to you know, a couple specific people, again, whose emails I will share with you if you're interested. So if you are interested, just let me know, and I will you know, direct you in the proper channels. Are we going to have a review sheet like we did for the midterm? Yes. So the game plan for this week, just jumping the gun a little bit here. The game plan for this week is today we're going to talk about the project packet, some do's and don'ts, some things that I saw on there that were common mistakes, some things that I liked on there, like some ingenuitive ideas. Tonight into Wednesday, you're going to have your final lecture, which is going to top off the trigonometry stuff, which I didn't post over Thanksgiving break because I just kind of assumed nobody was going to watch it. When I tried emailing some students, they didn't get back to me until literally yesterday. So I just said, there's kind of no point. So I'll post that tonight. You know, obviously have one last homework that correlates with it going into Wednesday. And on Wednesday, we will discuss the homework just to make sure that we all are up to speed with that, you know, that final lecture. And then Wednesday into Friday is when I'm posting your review sheet. So you're going to have a review sheet. And then on Friday, we're going to discuss that review sheet. And then we have one last class after that. So Friday is our like review sheet day. The stuff that I'm going to be that talking about correlates directly to that review sheet. And then Monday is your review day. So Monday is where you guys come in with questions. I'm not going to have anything planned. You come in with questions and you ask them. Yes, Kenny.
I don't have a question, sorry.
Okay, no worries. Okay, so as long as we're all up to speed with that, great. Again, so today, project packet, Wednesday, homework questions like normal, and Friday is when we're going to be going over the review sheet, which is, again, posted Wednesday night. The following Monday, which is our last class, you guys come in, that's your review day, so whatever questions you guys have for me, take advantage of it. So with that being said, we took care of the office hours. I talked about the email from the chair. Last thing, student evaluations. I really really care about student evaluations. I very much read them. I like, knowing the critiques that you guys have for me. I grade you guys all semester long. It's only fair for you all to have the opportunity to grade me as well, right? So I read every single one of them. I read every question that you answer. So please, 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 I am encouraging you to do the student evaluations, even if you're just like, this guy sucks. Just tell me something. Tell me, something about the class that you found to be particularly difficult, something that you think that I could have made easier. So that way, going into next time, I can, learn from whatever mistake the mistake was that, you felt was made. So student evaluations, I don't get to read them until 2 weeks after the final. So don't feel like, and also it's all anonymous anyway. So there's no pressure, nothing that you say there can possibly impact your grade. I have no idea who's writing what, unless, you choose to include some information pertaining to yourself. Yeah, again, just please do them, as I very much do care about them. Okay. Is the final going to be everything after the midterm or everything we learned in the class? The final is going to be cumulative, so everything we learned in the class. The reason it can't just be everything after the midterm is because there's a lot of stuff that we've done after the midterm where you have to be able to solve it, you need the prerequisite skills of the stuff before the midterm anyway. For example, you need to know how to factor. Factoring is just a skill that we learned in the beginning of the class where that was on the midterm, that is just going to show up basically wherever in algebra. And it's obviously showed up in many times over, even on your project packet, right? With logarithms, knowing how to break apart the logarithms and solving for x. So the ideas that we learned in the beginning of the class are still going to transfer over. So that's why it's cumulative. There's no way that I can, just say, nope, stuff before the midterm, brush it off. Don't worry about it. But yeah, so it is going to be, everything that we've been doing. Good question, though. Okay, so again, student evaluations, please do that. I very much appreciate it. I'd love to get, feedback, especially given the online class format, something that, I wasn't used to. And I'd like to, be able to have a bit of a critique. So going forward, I can make some changes as necessary. Okay, so before we get into the actual math of the project packet, let me just real quick do a quick breakdown of the grades of the project packet. And also, I want to talk about one of the questions on the quiz that I sent back to you, so quiz 10. So as far as quiz 10 is concerned, most of you guys did fine. I got to say, I'm not entirely sure why some people just didn't take advantage of the bonus. It was a free 2 points. I don't really know what was going on there. Some people just decided not to write anything for the bonus. So if you wrote literally anything, I gave you the 2 points, and if you didn't, then I didn't. I'm not entirely sure what was going on, but in any event, the bonus was a free 2 points as long as you wrote something. But the question that I'm talking about in particular was question 3, which basically was talking about a triangle. It was a right triangle, so right triangle. One of the legs was 3, one of the legs was 4, and it said that angle theta was opposite the shorter leg. So theta opposite the shorter leg is obviously 3. So you would set it up like this, where theta is opposite the shorter leg. I had some people who were putting theta as a side. Really try to remember, theta here is an angle. What we're talking about and what the quiz was talking about was trigonometry, right? So we're talking about angles now, and the functions that regard angles. So theta is an angle, and that angle was opposite the shorter side. So to find this missing side here, you had to use the Pythagorean theorem. So what do we call this side? If these two, if 3 and 4 are legs, what do we call the side that's opposite the right angle? Anybody can answer.
The hypotenuse. Hypotenuse.
Yeah, the hypotenuse. Exactly. So when we set up Pythagorean's theorem, what side is the side that's alone on the equals? So if we have a squared plus b squared is equal to c squared, which side is the c? One more time for me.
The hypotenuse.
The hypotenuse, exactly, yes. So we don't know what the hypotenuse is. So your c squared is just c squared. You don't know what the hypotenuse is. You can't possibly figure, you're trying to figure out what c is. You're solving for c. So your legs are 3 and 4. So that means you have 3 squared plus 4 squared is equal to c squared. And then you solve this, right? Again, the way that you solve this is the way that we set up every Pythagorean theorem, which again correlates to stuff that we learned even before the midterm, right? Pythagorean theorem was on the midterm. So all you do, you add them up, you take the square root of c, or of c squared rather, and you get c is equal to 5. Not plus or minus 5. Again, I'm still seeing this very small mistake where when you're solving for a variable, you get it stuck in your head that you need plus or minus all the time. Remember, this is distance. This is a length, right? So it's the distance between 2 points. We don't ever want negatives when we're talking about distance or length. So this is exclusively 5. So you get what's known as a 3, 4, 5 triangle. And then from there, the rest of that, there wasn't many more mistakes. Just figuring out what secant and cosecant were, which of course are going to be respectively hypotenuse over adjacent and hypotenuse over opposite. But regardless, again, most of you guys, if you got this much, you were able to get cosecant and secant. So I'm not too worried about going over that. Okay, so as far as the breakdown of the project packet is concerned, the average grade, or the average of the grades, came out to be an 81, which is I'm good with. I think 81 is a very solid number for an average for this for the project, so I'm fine with that. The number of students who had above an 80 was 17. So we have 24 students in this class. And 17 of you scored above an 80 or above rather, which comes out to be about 17% or 70% of the class. So yeah, I'm again also totally good with that number. That's generally where I'd want it to be. As I normally do, just to shout out to the highest couple highest scores in the class. I had one person get a perfect score. I also had another student get a 99, and then there were 6 other people who were all in the 90s. So congrats, you guys really took it in stride. I gotta say, in general, this isn't the case for everybody, but in general, the highest grades in the class correlated to people who attended office hours. I'm not saying you necessarily needed office hours, but to the people who came to office hours just to verify their solutions and just to ask questions, you guys ended up getting the better grades. So this should really speak to what I've been saying all semester long, which is come to office hours, ask your questions. I understand that anxiety is a big thing, and sometimes you don't want to ask your questions in front of 23 other people. Totally get it. Ask it to me on a one-on-one basis. Just, even send me an email, do something so that way you're still asking your question, because otherwise you just are left with this big unknown, and then you're submitting basically a giant question mark, which, it's really tough for me to give you partial credit. So please, again, I urge you guys ahead of the ahead of the final, utilize office hours, especially now that we're going to have 3 this week. Okay. So if you got above a 90, you're in great shape for the final. Keep doing what you're doing. If you got above an 80, you're okay. I might recommend coming to office hours just to shore up anything that, you might have messed up. But if you think you're okay, then sure, trust your instincts. If you got a 75 or below, I strongly recommend studying pretty hardcore before the final and also coming to office hours. Getting below 75 on this project packet, kind of indicative that either you were very, very rushed and you waited until literally the last minute to do this, which sure, maybe that happened, or you just didn't understand the material or what was being asked of you. Either way, still recommend office hours. And the last thing that I'll do here before we jump into the math is, if you are interested, I will tally your weighted grade ahead of the final. So what I mean by that is I will give you essentially your grade of where it currently is ahead of the final, so that way you have a decent understanding of what your max grade could be with the final if you get a perfect score, for example. Or what grade you need to get on the final to just pass the class, things like that. I took the liberty of emailing 3 students last night, just 3 people who are essentially at the top of the class, just letting them know that essentially, hey, you're doing great. So if you received an email from me last night stating so, then congratulations. But again, if you are interested, this applies to anybody. I'll let you know what your grade is. I don't have your weighted total calculated, so you know, if you ask me, it's going to take me a little time to generate it, but I can generate it for you. Okay, so that's an option that I'm laying out to you. Just email me on the side if you want that information. Okay, so now actually into the project packet. The biggest loss of points by far, indisputably, was people not following directions. That was it. That, like, indisputably, if you didn't follow directions, you lost the most points, and that's all it comes down to. And unfortunately, following directions isn't even a math thing. That's a reading comprehension thing. You know, if your English teacher says you need to double space your essay 1.5, or I'm sorry, you need to double space your essay and have, you know, like 7 pages worth minimum. If you submit 6 pages worth and you know it's 1.5 spaced, then I'm sure your English teacher is going to be pretty annoyed at you, right? Because you didn't follow directions. Same idea here. If you don't follow directions, you're going to lose points. So the directions at the very top of the project packet says, if a solution requires a check, please include it in your answer. And also, domains should be expressed in interval notation, which means if you tried to express your domain in anything other than interval notation, I didn't accept it. It had to be in interval notation because that's what we've been primarily focusing on. If something required a check, you had to include it. Now, with that being said, I did go ahead and forego the checks that you needed for number 8 and for number 10. The reason that I got rid of those and I didn't hold it against you was because of the fact that there's a chance I wasn't clear enough with when logarithms require a check. So I didn't hold that against anybody. If you didn't do a check for number 8 and number 10, so be it. You didn't lose any points for that. For number 10 especially, if you did every step correctly, you actually would have ended up with 2 solutions where one of the solutions would have been wrong. When I say wrong, it would have been extraneous had you done a check to show that. So if you got both of those solutions and you just didn't do a check showing that one of them was extraneous, then so be it. Again, I didn't hold it against you. What I did was I checked off the correct one and then I wrote okay next to the one that was essentially extraneous. So the one that would have required the check. So when extraneous solutions can occur correlates directly to having a problem in your domain. Real quick, what are my 3 rules now for domain? 2 of them we've been talking about all semester long. One of them is new and pertains to logarithms. What are my 3 rules of domain, guys? For the record, this is, your last chance to earn participation credit. So trying to throw you some softballs. Please get your participation credit.
It can't be negative under a radical. It can't be negative under a domain, and I'm forgetting the third one.
Yeah, and Deborah has you covered for the third one. So the denominator can't be 0. If you have, for example, 1 over x, right? If you have a fraction, your denominator cannot be 0. If x is 0 in this case, then you have a problem, right? 1 over 0, you can't divide by 0. Try plugging 1 over 0 into your calculator and then let me know how that works out for you. The answer is it won't, right? So can't divide by 0. So that's your first rule. Second rule is one that, again, just like Zenaida and Gabriella both said, you cannot have a negative underneath an even root. So if you have a square root, for example, and you have -1 underneath of a square root, this is going to break. This is not allowed. You can't have this. We call this a complex number, right? We define this as I, but this is not a real number. Hence, it is not in the domain of real numbers. So that's our 2 rules that we've been talking about all semester long. And the third one and the newest one is if we have some logarithm with some base and we have the logarithm is on the value of x, we know for sure that the domain of a logarithm has to be positive. So we know x has to be from 0 to infinity. Okay, so Just keep in mind those 3 domain rules. So with those 3 domain rules, that's when you can get an extraneous solution. So the 3 questions on the project packet that you absolutely had to do a check for were number 2, number 8, and number 10. Number 2 you had to do a check for because in number 2 you had your variable in the denominator of a fraction. Number 3, although number 3 you have that same situation, you don't need to do a check for because this is an inequality. You have to do it in an equation, but when you're talking about an inequality, you no longer have to do that, which, again, something that we discussed with inequalities, which we'll get to number 3 in a second. And again, one more time, if you didn't do the check for number 8 and number 10, again, you didn't lose credit. If you did do it, great. I didn't throw any bonus points this time around, but it's good that you have that understanding that you needed to do the check for those logarithms. Okay. So jumping into this, question number 1, I'm just going to kind of skip. Almost like by and large, everybody got it correct. If you didn't, the only actual problems that I saw on number 1 was just not knowing the type of linear equation, which, I mean, to be fair, we talked about it and it was in the lecture, but even if you didn't know where it was in the lecture, you could have just Googled it and found the name, right? Like this is, I feel like that's something that, was absolutely possible. So in any event, if you just got the type of linear equation wrong, I took off 2 points. You still got the majority of the credit just for showing that, it essentially boils down to x is equal to x. So if you got x is equal to x, if you got 0 is equal to 0, if you got 7 is equal to 7, as long as you got the same thing on both sides of the equation, then you got most of the credit just for doing that. And then you would have gotten the other 2 points just for knowing that this is an identity. We know it's an identity because you have the same thing on both sides of the equation. It's identical. That's, essentially where it's coming from. You have infinitely many solutions for x. X doesn't matter. Notice how it doesn't matter what value you have for x. It's always going to be true, right? So it's an identity, not inconsistent. I don't think anybody actually put conditional, so that's good. All right, so for number 2, again, just to quickly go through this. So there were actually 3 different kind of substitutions that you could make. Again, the biggest loss of credit here were people not following directions. It says solve for x using substitution. If you just solved for x, if you just multiplied the x minus 1 squared and, just to clear your denominators and you solved for x, then you only earned like half credit because, okay, you got the correct answer, but you didn't do it the way that it was supposed to be intended. So, and you also would have lost another additional point had you not done the check for your answers, regardless if you use substitution or not. So the way that you have to do this, and we'll just write out the question, x minus 1 squared plus 9 over x minus 1 is equal to -9. The way that you have to realize this is, again, when you're trying to solve for x using substitution, when we originally learned this, we learned this for quadratics, right? So quadratics are in the form ax squared plus bx plus c is equal to 0, right? Where c is your constant, and in this case, our constant is on the other side of the equation, but that's okay. Again, the idea here is we're just going to be trying to substitute so that way we can make it look like a quadratic. If we can make it look like a quadratic after substitution, then we can apply our normal quadratic rules and, ways to solve things. So that's your game plan here. So the 3 different substitutions that you could have gone for here, you could have done the easiest substitution, which is just getting rid of x minus 1. If you just got rid of x minus 1, just to write this in red, you would have substituted directly for x minus 1, and I'll just put this as a. So you would have had something like 2 over a squared plus 9 over a is equal to -9. These are a's, not 9s, on the denominators. So if you did that, that's an acceptable substitution. I let it go. It's not the most accurate substitution that you can make, but it's something. And as long as you did the rest of the work correctly, you're okay. So at this point, you would multiply both sides you would multiply everything by a squared. And multiplying everything by a squared, you would be left with 2 plus 9a is equal to -9a squared. You bring that 9a squared to the other side. So that's going to look like 9a squared. And voila, you have a quadratic now in standard form, right? How do you know it's a quadratic? Your biggest power is a 2. followed by a power of 1, followed by a constant, right? This is now a quadratic. You can solve a quadratic. Hooray. So that was one approach. The slightly more accurate approach was just saying, okay, well, I realize that x minus 1 is in the denominator, and if you use the hint says, oh, I could bring anything up from the denominator as long as I just negate the exponent, right? So you could have said, okay, well, this is really 2 times x minus 1 to the negative 2 plus 9 times x minus 1 to the negative 1 is equal to negative 9, right? And if you got this far, you would have realized, oh yeah, I'm trying to get a power of 2, I'm trying to get a power of 1. So using the other hint or the other exponent rule, you essentially just break that exponent into 2 exponents, where it would look like 2 times x minus 1 to the negative 1 power with a 2 on the outside, because again, you want this to be your highest power, plus 9 times x minus 1 to the negative 1 to the first power is equal to negative 9. And then you make your substitution, but this time, instead of making your substitution for x minus 1, your substitution is now going to be b is equal to x minus 1 to the negative first power. So now you would have 2 times b squared plus 9 times b is equal to negative 9. This is a totally acceptable way to go about things. Again, notice now the difference here. Your b squared, the coefficient of your highest power, is now 2, as opposed to it being negative 9 as it was in the previous substitution. So depending on the substitution that you made, your quadratic was going to look a little bit different. So that was the second way. And the third way, which was probably the most accurate way, I only saw one student do this, but that's okay. The third substitution that you could make is recognizing that this is a fraction, right? Both of these are fractions. But what we can do is, in any kind of fraction, you can always take your numerator and move it out front as a multiplication, and then you would just have a 1 up top, right? So we can rewrite this as 2 times 1 over x minus 1 squared plus 9 times 1 over x minus 1 is equal to negative 9. And then the student realized, oh, well, this 1 to the first power is the same thing as 1 squared. So this is essentially the same thing as the entire fraction being squared. So at this point, she made the substitution for 1 over x minus 1, but realized that 1 over x minus 1 is really the same thing as x minus 1 to the negative first power, which is exactly like we talked about in the last example. So regardless how you made your substitution, I just needed to see a substitution. And then you solve for your whatever your substitution was, your new letter. You get 2 answers for that. You then go back to the substitution that you made and you solve for x. Some people stopped at the substitution, like they set their new letter to be y, for example, and then they solved for y, but they never solved for x. So you would have gotten most of the credit there, but again, understand the question says solve for x using substitution. So if you stopped early, you didn't get all the credit. Okay, so that was number 2. No real giant hiccups there. Again, just following directions, right? Number 3, the same exact thing. I'm not going to spend too much time with this one, but I do want to hammer in a couple points here. So number 3, some people tried doing this without test points. If you didn't put test points, you lost half credit like immediately. Test points was the biggest part of earning credit for this question. So if we have x squared minus 4 over x squared plus x minus 6 is greater than or equal to 1 over x plus 3. Okay, so with inequalities in general, there are 2 rules that we have to follow that are very, very different than in an equation, okay? If I gave you this, for example, if I gave you the same exact things, where hypothetically, instead of it being a greater than or equal to, I gave you an equal sign, these 2 rules that I'm about to talk about go right out the window. The reason that they go right out of the window is because it's acceptable to do the 2 things that I'm about to talk about in an equation, but in an inequality, you absolutely cannot do them. Okay, the 2 things that you cannot do are you cannot cancel your terms involving your variable in a fraction. So if you have, x on the top and bottom, you cannot cancel out that factor. It's not allowed, and we'll see why in just a second. And the second thing that you can't do is you cannot multiply or divide by your variable. The reason that you can't do this is because you don't know whether or not your variable is negative. If your variable is negative, or the term that you're multiplying involving your variable is negative, then you'd be switching the sign, right? Remember that multiplying by a negative or dividing by a negative involves switching the sign from a greater than to a less than, and vice versa, right? So if you don't know whether or not, like, x plus 3, for example, is positive or negative, who's to say if x is negative 17, for example? If x is negative 17, yeah, it's negative 17 plus 3, but that's still negative. And then if you multiplied it, then you would have had to, switch the sign, right? But the idea is you don't know what x is, so multiplying by x plus 3 to clear the fraction isn't going to work out. Now, I want to take a very, very quick second here to say there is another approach to solving inequalities, and I think this is where maybe some of you are getting confused, because maybe this is how you were taught before. I saw a couple of people try to approach this question using this different rationale, and although it's not incorrect, it leaves you open to making a lot more mistakes, and that's part of the reason that we don't teach it that way. So the second way that you can solve inequalities, and I'm only showing you guys this just to show you that there is an alternative method, but it's not exactly accurate. The second method is by multiplying by your LCD, but there's some giant pitfalls with that. So what you would do is you say, okay, well, I want to get rid of fractions, right? So how do I get rid of fractions? Getting rid of fractions means I'm going to multiply by the denominators of both fractions, right, on both sides. So that means on the left-hand side, I'm going to multiply by an x plus 3, and whatever I do to the left, I also do to the right. And I'm multiplying by x plus 3 to clear the fractions. And also, I want to get rid of this denominator, the bigger one here, which is the x squared plus x minus 6, right? So we do that there to clear the fraction on the left, and we do the same thing on the right, just because whatever you do to the left, you also have to do to the right, right? So if you did this, which is, again, kind of what I saw, this is incorrect because of exactly what I told you guys before. You don't know whether or not your terms are positive or negative, so you don't know whether or not you're flipping the sign. The alternative makes it that. Now, before I explain that, remember what squaring a number does, right? If you have 3 squared, you will always get a positive 9. If, similarly, you have negative 3 squared, you still end up with a positive 9, right? So what we can establish is that squaring any number, positive or negative, as long as it's a non-zero number, will result in a positive number, right? Squaring something makes it positive. So the loophole here is, okay, you multiply by your LCDs, but it's not just by your LCDs. You're multiplying by your LCDs squared. And this is, again, something that I saw like 1 or 2 of you try, and it's a nightmare. It's an absolute nightmare. I mean, look at the polynomials that you're going to be multiplying here. You're going to have, on the left-hand side, x to the 4th power when you fully factor things out. And I mean, if you want that, good luck. That's fine. If you want to deal with x to the 4th power and, all the following terms that fall out of it, sure, why not? But there's a very good reason that we don't teach it this way. So those reasons are other professors here at the college don't teach it that way. So at SUNY Oneonta, they don't do this. It's not in the textbook, and I follow basically exclusively from the textbook in case you guys have it. And also, it's definitely not intuitive. You have to remember to square everything that you're multiplying by, and also you have to double check your discontinuities. So what I mean by discontinuities is if we have a number line and we find that a number should be an open circle, we call that open circle a discontinuity, right? If, the graph looks like this, then there's a discontinuity in the graph. And we know that this whole happens at a particular number, because at that particular number, that's what makes your fraction undefined, right? That's where you get a 0 in the denominator, and you can't include that in your final answer because you're dividing by 0. So the benefit to not canceling is that you keep track of your discontinuities all the way through. So if you did it the normal way, the straightforward way, then you would know that you end up with a fraction where your fraction is, I believe, somebody correct me if I'm wrong, but I believe you get this for your final fraction after everything is fully factored and moved over. And so you get essentially this inequality. The benefit to not canceling the x minus 2 here is that when you go to graph, you know that at 2, you're going to have a hole on your graph. And this hole is something that a lot of people missed. Again, the way that you figure that out is you set every factor equal to 0, just like we've been taught. So you'd set x minus 2 is equal to 0, x plus 1 is equal to 0, and x plus 3 is equal to 0. And you would get x is equal to 2, x is equal to -1, and x is equal to -3, which is the numbers that you're plotting on your number line, right? Again, most people got this far. So if you did, that's great. You would have had -3 here, -1 here, and then 2. But notice that at 2 and at -3, you have to put open circles because they're in your denominator. So again, the benefit to not canceling is that you keep track of the discontinuities that can arise. If you canceled and you still made sure to put, an open circle, and you got the correct the correct final interval, which came out to be all the numbers up to -3. This was a closed circle on -1. All of these numbers up until 2, and then all of the numbers after 2. So writing out this interval, you would have gotten. You would have gotten this for your final interval. If you got this and you did your cancellation of the x minus 2 on top and bottom here, I didn't take any points off, although I did mark, hey, just don't do this in the future. Just, keep track of things. But if you canceled and you didn't get the correct answer, then that's where I took off points, because canceling is what led you to miss this hole right here at when x is equal to 2. Okay, so that was really the biggest pitfalls for number 3. Some people tried going right to test points before things were fully factored. You can't do that. Things have to be entirely factored before you can do test points. Again, the biggest problem was just with the cancellations of the x minus 2 on top and bottom. Okay, number 4, not really a whole lot to talk about. Number 4 was the absolute value question, where essentially if you had 2 absolute values, so x squared minus 2x is equal to nx minus 10, right? 2 absolute values on both sides, then you're gonna have 2 different cases, positive and negative case, right? You choose a side to be positive always, and you make the other side positive or negative. This is just going back to absolute value rules. Number 4, there wasn't really a whole lot going on. You just had to solve in terms of n. And Deborah, we can talk about that after class if you think that there's a problem with your project packet. So again, with this in particular, you're going to have 2 different cases, positive and negative. So all you're doing is you choose one side to be positive. So for me, I chose the right-hand side to be positive. It doesn't really matter. You can, regardless which one you choose to be positive always, you're still going to end up with the same answers. So you have nx minus 10 is equal to x squared minus 2x. That's your positive case. And then your negative case is nx minus 10 is equal to negative x squared minus 2x. And now all you're doing is you're just solving for n. Because again, it says solve in terms of n, which means get everything that's not n on the other side of the equation. So to do that, just add 10 on both sides. So you get nx is equal to x squared minus 2x plus 10. Over here, similarly, you're going to have nx is equal to negative x squared plus 2x plus 10. And then you're just going to divide everything out by x, right? So n is all by itself, divide by x. N is by itself, divide by x. And that's it. You get 2 different equations in terms of n. And then for part B, you're just plugging in x is equal to 2. Because it says if x is equal to 2 is a solution, find the value of n using either of the equations that you solved for in part A. So you're just plugging x is equal to 2 into either of the equations that you just solved for. And for either of them, it doesn't really matter which one you pick, you will get n is equal to 5. So that was the correct solution there. Number 5 and number 6 were by far the hardest questions on the packet, like indisputably, because they have a lot to do with domain, and the way that you find the answers aren't exactly clear. There's, you have to fiddle around with numbers. You have to do a lot of playing around for things to start to make sense. So just to quickly go over number 5, for part A, it says find f composed with itself. Remember, guys, again, I saw this mistake with a couple people. F composed with itself is not the same thing as f times f. These are very, very different. F times f is multiplication. F composed with itself is saying that you're going to have an outside function and an inside function, right? This, same thing as if, you had a different letter instead of, 2 f's. If it was f composed with g, you're still going to have an outside function and an inside function, right? So our result here is that we get f of x, right? Outside function, inside function. But you know what f of x is. F of x was 1 over x. So you would have f of 1 over x. And now this fraction is your new input for what you're plugging into your function f. So wherever there's an x, that's what you're plugging in for this fraction. So the original function was 1 over x, but instead of it being 1 over x, you have 1 over x, which comes out to be x. So cool, that's part A. You get x. Part B says show that f of x is different than g of x. And again, a couple people just said, nope, it's the same thing, and just moved on. It was really hard for me to find partial credit. If you tried showing other things, then I gave you as much partial credit as I can give you for that. But they are very different. And the reason that they're different comes down to their domains. So their domains, if you did the work, you would find that the domain of the composite function, which I'm just going to illustrate as a d here, you get from negative infinity to 0, union with 0 to infinity, because notice what happens when we plug in 0 into our inside function. Remember, our inside function is 1 over x, right? If you plug 0 in for x, you get 1 over 0, so it falls apart. The domain of a composite function takes into account the domain of the inner function as well. So you would have had to show that to get full credit. So you get the domain is this piece right here. We know that the domain of g of x, which I didn't require any work for this because g of x was just x. So we know that the domain is all real numbers. So as long as you showed that these two domains were different, you got full credit, or almost full credit if you made like a tiny small mistake. But either way, you would have gotten most of the credit here. Number 6, I will go ahead and post solutions to because it's just too long and we're running out of class time here. But it's something that definitely would have taken a little bit of effort. If you were confused on composition of functions, and if you were confused on how to find domain, then you would have ran into some really big problems here. I will say, there was a really nice trick that a couple of you guys did, which was you could rationalize, and rationalize could make things a little bit easier for you, but only if you rationalize twice, which is why when people ask me, should I do that? I said it's not really required. You don't necessarily need to. So if you rationalize twice, then it made your solution for part B a lot clearer, and that would have possibly helped you out with part C as far as finding the domain. So, if you did that, then great. If not, then, there was absolutely other methods that you could have taken to find the answer for number 6. Number 7, the biggest problem with number 7 was just that a lot of people didn't understand what factor theorem was. I know I'm about to run out of time here, but can somebody just tell me what factor theorem is? So if I have, I'll just actually write this out. If I have x cubed minus 13x minus 12, and part B says using factor theorem, show that x minus 4 is a factor. So x minus 4, what is factor theorem? What's my process here? What do I actually have to do?
You plug it into the x's.
Yeah, so what you're doing is you say, okay, well, if x minus 4 is the smaller polynomial, what I'm doing is I'm taking this number, remember, you're negating that number, and you're just plugging it into your bigger polynomial. If, when you plug that number into your bigger polynomial, you get a 0 back, then by factor theorem, the smaller polynomial is a factor of the larger polynomial. So all you're doing is you say, okay, well then, f of 4 is equal to 4 cubed minus 13 times 4 minus 12. And I'm not going to go through the work. You guys can obviously do this. But yeah, it comes out to be 0. And that's it. That's literally all you had to do. You just had to put 3 lines of work. This line, the line where you simplify, and then the line where you get equals 0. If you got that, great. You got full credit. That's factor theorem. That's all there is to it. Some people tried using synthetic division. Unfortunately, that just wasn't the directions. So you lost points there because, yeah, you had to use factor theorem. Number 8, there were no big hiccups. People pretty much seem to get that one entirely correct. If you just follow the hint, you converted to exponential form, you were basically all set. Number 9, this is the last one that I'm really going to cover. Because number 10, there really weren't any giant mistakes. So with number 9, I gotta say, I was very impressed with a couple people. There were 2 different ways to handle number 9. So it was the n is equal to 2 to the 3/4 power. And then you were also given n to the b is equal to 16, and you were trying to find b, right? So the 2 different ways that you could approach this is you could either approach it using exponents, which I found to be the more intuitive way when, trying to guide you guys through office hours. But again, I was really impressed with a couple students who went the logarithm direction. So what some of you guys saw was that, oh, well, if I had a logarithm on n, with the power rule of logarithms, I could pull that the b down, right? So basically what they did was they took logarithm on both sides on both equations. So you had log n is equal to log of 2 to the 3/4. And then also for the other equation, you would have had log of n to the b is equal to log of 16. Right? And you don't have to use log base 10. It could have been any log with any base, but log base 10 is just the most intuitive. If you use the natural log, totally fine as well. Regardless what you came up with, you get to the same conclusion anyway. So eventually all you're doing is you take your b, it comes out front, and you're doing the same thing with the 3/4 power, comes out front, right? And so all you're doing is you're substituting in for log of n. And if you did that, then you would have been able to find a solution. It just would have involved using change of base formula. So at some point along the lines, you would have had log of 16 over log of 2. And some people got stuck here and they thought they needed to use the quotient rule. Remember, quotient rule is the subtraction of 2 logarithms. If your logs are already being divided, then you can't use quotient rule. This is change of base formula. What you're doing is you're saying, okay, well, I'm going to convert this back to 1 logarithm, and my bottom value becomes the base, and the top value stays as the value. So you would have had log base 2 of 16, which would have ended up to be 4. So this is just 4. And then you would have solved for b because you would have had 3/4 b on the other side. So in any event, regardless how you accomplished it, great job. There was some flexibility with this one. And then number 10, again, no big problems. I'm going to go ahead and end the recording here. If anybody wants to talk about their particular scores, if you think that there's a problem, feel free to let me know, and we can, work it out, whatever the case is. Okay, so I will see you all on Wednesday, and enjoy the rest of your day or office hours if you are coming to that later today. Have a good one, guys.